All right. So in today's session, we'll be learning stacks. So does anyone know about stacks? What stacks are? Wait a minute, I guess my audio is on it. So stacks are a very basic, idea. Same as for the as the name went for queues, same goes for stacks. Stacks also, are very similar to the real world stacks. That the meaning of the stack word. We can say a stack of books or maybe a stack of objects, if you see. So in Python also the data structure stack works the very similar way in the real world. Let's see an example of how a stack would look like. Uh, how do I start this video? Yeah. So over there you can see that this is an example of stack. How someone can put gym weights in the form of a stack. So one above the other. So 55 would be the top stack, and 50 top element of the stack, and 50 would be the bottom element of the stack. So in stacks also we have the some similar properties relating to queues, that is push, pop, and peek. The difference between queues and stack is that in queues we had the FIFO structure, that is first in, first out, that whatever item was entered first, it went outside also first. But in stacks, it is a little different. That is that it goes by the LIFO structure. LIFO structure, that is LIFO, that is last in and first out. So whatever element you keep on the stack at the last comes out first. For example, imagine a stack of books. So the top book would be kept at the last, isn't it? And that is only the book that you can take out at the first moment. So that is how stack works basically with a LIFO structure. And we have then three functionalities: push, pop, and peek. What push does is it adds to the top of the stack. So for example, if I do push 65 on the right hand side stack, 65 number weight would come on the top of 55 number. What pop does is it removes the top of the stack. It removes the data from the top of the stack. So if I do pop on this gem weight stack, it would remove the 55 uh, numbered weight. Also, we have the similar function from the queues, that is the peek function, which what it does is it shows us the data that is on the top of the stack, or the first element on the top of the stack. So if I run the peek uh, function on this gym weight stack, it will give me 55 itself. So this is just a video showing stacks. So we push 50, we push 60, we push 55, then we pop 55, and then we peak again. So we get the 60th number. So this is simply how stacks work in a very simple way. Implementation of stack could be again done through using nodes or linked lists. Over here, we only have the attribute for top element. We need not see what the bottom element is. So, as we had in queues, we had the tail node also, tail node attribute, which told us about the tail node. So in stacks, we need not, have that attribute in the first place. We could only have the top element attribute, and that would do our work. Because all the functionalities just deal with the top element and never the tail element or middle elements in a stack. So that is it. Similarly, as similar in the queues, we also have some corner cases. So in stacks also there are the two similar corner cases as same as queue, that is stack overflow and stack underflow. So stack underflow happens when we try to remove a data point from an already uh, we we remove a data point from an already empty stack. So then stack underflow happens. Stack overflow is the same if we have a bounded stack, that is a stack with some limit in memory or the number of nodes, and the memory is reached already. That is, the stack is full. And then also we try to push some element in the stack, then the problem of stack overflow occurs. So these are the basic functionalities of stacks. We covered the corner cases, that is stack underflow and stack overflow. And we also have the attributes, that is the top of the stack, and the other two attributes are, as usual, the size and the max size or the limit of the stack. So if you have any doubt in the working or the concept of the stacks, just let me know and we can solve it right over here. Or else we can move to the coding part and then to the quiz part. Does anyone has any doubts? So yeah, do anyone of you have any doubts? Then just let me know before we do the coding part in the concept itself. If not, just let me know. We can if we can move further. Can I move forward further? Uh,
Yes, Bhaiya.
all right. Thank you a lot, Samragni. So in stacks also, as we did for queues, right? Then when can we add a node to the queue? When can we do what? When can we enqueue? When can we dequeue? We had some cases for each of the function. So similarly in stacks also we will have some cases and for each. But before that, let me define the normal functions that we needed. That is the dev has a space function which gives us if the stack has some space or not. So but it uses limit and size. So let me just go from beginning itself. All right. So I've imported the node class. The node class, as usual, has the same methods. That is the set an x node, get an x node, and get the value of a node methods. So it is the same as usual. Then let's come and define the stack class itself. So the definition of the stack class would be as usual class named as stacks. Can anyone tell me what parameters would it take over here? Anyone? Someone please. Come on guys, this is the last class. Live in it a little bit. At least not for you, then for me at least. Can someone tell me what would be the parameter for the class? Please? No one?
There would be no parameter.
Exactly. The class definition has as such no parameter. The initializer or the constructors or the other functions have the parameter. Would work somewhere. So let's define the constructor. So as usual, using the init method or the dender method, one of the dender method. Dender method again means the double underscore methods that we have in Python. So let's define a stack. In stack, we have the simple self parameter. Also, we have the limit parameter or the max size parameter. So this time, instead of setting to none, let's set it to something else, maybe 100 or yeah, let's 100 or maybe 1000. So this is the init method. In the init method, we set the initializing. So we set the top item You have to set the top item of the stack. We only need the top item because we work with the top item itself. We do not work with anything else. We need to set the size of the stack and we also set the limit of the stack. So the top item of the stack would be, for now it would be none because we don't have any top item as of now for an empty stack, right? There isn't any stack itself. So until and unless we push something into it, the stack would be empty. Similarly, the size also would be 0 for the starting case, and the limit could be limit could be whatever we give it. So limit could self dot limit could be equal to limit itself, and in the default case it would be 1000, right, if we don't specify it. Now the usual methods, that is the has space and is empty functions, is empty methods for the stack class. What has space does is it tells us if the stack has some space or not. So it returns that if limit is greater than the size, so it will return us true that it has space. If it's not if it's not greater, if it's equal to or something else, then it will return us false, that the stack doesn't has any space. Similarly, the second preliminary method we are going to use is the is empty method, which tells us if the stack is empty or not. Both of these methods help us to solve the counter cases or the corner cases, that the problems that we have of underflow and overflow. So can someone tell me which problem will has a space method help us solve, underflow or overflow? And similarly for is empty too.
Has space helps solve overflow problem.
Exactly. So if we don't have space and we are try to add it, it will have the overflow problem, and the vice versa for is empty method that solves helps us solve the underflow problem. So these help us tackle those two corner cases. Now let's define the three functionalities, the normal functionalities of the stack. Uh, First, let's define the peak function. What will the peak function take in the parameters? Line by line, now you guys could tell me, isn't it? We've done queues, we've implemented linked list. Yes, you could just tell me line by line what should I type. Maybe we could take one by one.
Self.
Yeah, Mohajit. All right. So it will take the self. What will the peak function do? Is the peak function do?
Return the topmost element value.
Exactly. So it returns me the topmost element. So that is self dot top item. But we don't need to know the top item itself. We need to get its value. So we return the self dot top items value. So how could we get the value? We can use the get value function for that. All right. But what if the stack is already empty? So to count that also, we need to have some lines, isn't it? So let's see that, let's put it over here, that if the stack is empty, if it's empty, then we will simply print that the stack is empty. And if it's not, then we will print this little return line. So if it's not, self is not empty, self dot is empty is not true. If it's not true, then I'll print this return line. Else I'll simply print that the stack is empty. All right. So this is our peak function, and simply optimized peak function that we define for the stacks. Now let's come to the pop function. Again, would take something very similar to the peak function, that is only the self, because it won't take any parameters other than self. It will simply remove the element that is already present in the stack. So for pop, we need to have those similar cases that if the list is already empty, then we cannot pop. So we show that the list is empty, you cannot pop. If it is not empty, then we can pop. Over there also we have the case that no, but then we don't have. So yeah, it's very simple in stacks that if self is empty is not true, is not true, then we could do our removal work. Else we could simply print out something like that. The stack is empty and not pop. All right. And so I guess it's clear up till now. Now, what if the stack is not empty? I mean, it has some elements, and so we can simply use the pop function, right? To use the pop function, we need to initialize which node we have to remove. So we have to remove the top node, isn't it? So let's make a node variable item to remove and set it to self dot top item or top node. What did we top item? So let's set it to top item. All right. So the top item would be removed after it. Now what we do is if we remove something from the top of the stack, now for example, 1, then 2, then 3, then 4, then 5. This is a stack. Now I want to remove, I want to remove this. I want to remove this. This is the top item as of now. This is also the item to remove as of now. Now, after I remove this, before I remove this, I have to set its link. I mean, I have to set the top item as 2, right? We have to set that top item as 2. So then the Python will do its thing and it will, collect the garbage and one will be destroyed automatically. So we have to set 2 as the top item, right? How could we do that? We could say that now the self dot top is equal to item to remove the next node. This kind of first ka next node would be 2. So we can say item to remove ka next node. So how could we use that? We could use the get next node function over here. Get next node. Was it get next node? Yeah. We can move the get next node function over here. Where are we? Yeah, over here. We can use the get next node function in line 25. So this is we've now the top item is not 1 but 2. Now 1 has no linkage. 1 is not the top item of the stack. It's nothing. So the Python will do its garbage collection and it will remove it from the memory. All right. Now I also have to do something after I remove. What do I have to do? Can someone remind me? Can someone? We have to decrement the size. So since we've removed something from the stack, we decrement the size of the stack by 1. In this line number 26, I decrement the size, and then I could, simply I could do that, return the value of what we've removed. So item to remove key, I can give out the value. Key item to remove key get value. function used. Okay, I could tell the user the value that he just removed. Or like just for verification purposes, I could also skip this 27th line totally. All right. Now this is the simple pop function that we just made. If the list is not empty, then we do the removal part. If the list is empty already, we cannot pop, so we give out this message. Also, if we are removing, we set the next node as the top as the new top item in line number 25th. And in line number 26, after removing, that is after setting the top node, the new top item, we also decrement the size with 1. All right. Now let's define the push method. All right, let's define the push method. What does push mean? Push means adding something. So if you are adding something, you need to tell that I'm adding something and this is the value of it. So that means that not only we have to take the self parameter, we also have to take some value parameter to be given to push into the stack, that is to be added to the stack. So now, as similarly, we took some cases for just a minute. Guys. All right, guys, sorry. So, in the push method, I again have to check if the stack is already full, we cannot push something into it. That is, if the stack has some limit, maximum limit, and if the limit is already reached, I cannot push anything into it. So I have to check that. So if I can check that using the has a space function. So if self dot has a space, since it's a function, I have to add these curved brackets. So if the has space function is true, then I'll do the adding part. If it's not, that is else, I'll print, I'll print something. Uh, space stack is full, cannot push into it, right? I can also again use the format function that I told you guys about. The format function that this stack is full and I could add something in between the strings without using the plus operator. So I could also do that as usual. Now in the if part, I have to add something, right? So if I have to add something, it should be a node, isn't it? It should always be a node. So to do that, I'll make a variable item to add, or I can simply item, and I initialize it as a node so that I could actually use the node class, and I'll give it the value that we get from the definition itself. So this is I've made a node new. Now I have to connect it. This is making node itself. Now I have to do the connection part. So how could I connect it? For example, if I have a stack of 1, 2, 3, 4, I want to add something to the first, like the top. I want to add I. Now I cannot simply add, the first thing is I cannot add to any other place. So it will only get added to the top because this is the normal functionality and concept of stacks. So if I want to add something to the stack at the top, what would I have to do? I would have to set the next item of 1. Like 1 ka next item should be I. So if I do that, similarly I would like Consequently, I would be connected to all of them. So I have to do this, right? I have to set first जो अभी का जो top element है, like one is the top element of for now, top element. So I have to set the top element का next node to I. Isn't it? Isn't it? So let's do that. So what I'll do is I'll set item, yeah, item dot set next node. Next node to top item. Is it good with everyone? Now tell me why I said that I have to set one connects node to I, but I set I connects node to one. Why did I do that? Can someone tell me? Because stacks are unidirectional. We don't have the previous node property in stacks. You see in the class itself we don't have, even in the nodes that we've defined we don't have the previous node property. We simply have the set next node property. We are using the singly linked list over here. We are not using doubly linked list. So we have to set I का next node as one. अगर if we use, we cannot have one का previous node to I. We are using simply single list. So that is why I have used I का next node. I've set to one. That is the current top item. And then I could set the top item. That is self dot top item. Item to item itself, the new node that we have. And after doing that, I also have to increment the size. So self dot size would be incremented by one. Is it fine? So this is the whole push function that we have for stacks. And also we can, return after, adding something that we've return and the key item added or something like that. If you want to, just for verification purposes and make the graphical user interface better. So this is the push function. What we did was we checked if the stack was having some space, then we did the adding, all the adding part. So in the adding part, we did the initialization of the making of the node. Then we did the connecting part, then or connecting or the linking part, I should say. The linking part. Then we also set the new top of the stack. We incremented the size of the stack and we simply return with something to just verify. If the stack doesn't have some space, we outputted or returned the method that the stack doesn't has any space and you cannot simply push into it. So this is it, guys, with the stacks. Since we already did queues yesterday, I hope the understanding it today was little bit easier for you guys. If you have any doubts regarding to the code or the concepts, just let me know. If not, we can try out the quiz right now. We can discuss those answers and then we could show you what projects you could do. Simple mini project. So yes, tell me. No doubts. Should I give you the quiz links now?
Yes.
All right. I'll give you the quiz link. Right perspective, God's tattoo, lashes and diamonds, Aditi, she's found, well, dreams, been through some bad shit, but these kids wouldn't tell me. I know I myself fire. Alright. Oh my god. Alright. Guys, put the link in the description. Please attempt the quiz. And after like 10 minutes at 18:15, 18:14, let's discuss the quiz answers. No, not even 18:15. At 18:10 itself, because it has only 5 questions or so. So, yeah, let's just get back quickly.
Hello, hello Anmol.
Yes, Mohammed. Tell
Yeah,
me.
actually my quiz link is not opening because of the slow internet I have. If it is it okay if I don't attempt it right now?
Yeah, it's totally fine. Anyways, we're gonna go through the quiz, uh, you know, together. We'll discuss the answers together, so it's not a problem at all.
Okay, okay, great. Thank you so much. Okay.
All right, guys. So let's discuss the quiz answers. All right. So the first question is, if I pop the value from the following stack, what value would be returned? What would the new stack look like from top to bottom? So the top of the stack is for 55 and the bottom is 50. So whenever we pop in a stack, we remove from the topmost element. So 55 would be returned or popped out. Also, the new stack should look like 60 and then 50 on the top. So first option would be the correct answer. If the following stack was implemented using a linked list, representing with the header node of the linked list representing the top of the stack, what would the linked list look like if 40-pound gym plate was pushed onto the stack? So if we add 40, 40 should add to the top value that is above 55. So then it would be 40, 55, 60, and 50. So 40, 55, 60, and 50. Now find the method name. So we had just three methods. Peak wasn't this much long. Pop and push were there. So in push, we incremented a size, and in pop, we decremented the size. So here we are incremented the size, so it's definitely push. In init, yeah. In init, what purpose does the self dot limit equal to limit line serve? That is the the fourth line in this box. What does it do? First option is it sets a limit for the number of stacks that can be created by the stack class. It sets a limit for the number of nodes that can be added to a stack at any one time. Third is it sets a limit for the number of strings that can be added to a stack. We are not adding some strings, so this is not related. Third is totally crossed out. Fourth is it sets a limit for the total number of nodes that can be ever instantiated within the class. No, if if we increase the limit or something like that, we can it's not the total number as such. It's the max number. So first is it sets a limit for the number of stacks that can be created with the stack class. The problem is when we add anything to the stack class, we add it through nodes. So stack class isn't very necessary. Instead, it is the limit for the number of nodes that can be added to a stack at any one point. So second option would be the correct answer. You can traverse through the nodes of a stack. No, you cannot. We never, in this session, we never made a method, that which would go through all the stack points and stuff like that. So answer would be false. Although we can, but we never did it. So, yep, that is it with it. So response 3 was right. Now, actually, I made a few quiz projects from Code Academy platform itself. I compiled them into the Jupyter notebook for you guys. I could show them to you now, and you could try them afterwards. I'll send the file. So my Anaconda software will take 2-3 minutes to go through, like open. Till then, I would request you all guys to fill the feedback form. Uh, it it's not necessary, it's not mandatory as such. It's your choice, but I would heavily request you all to do that. So Please fill the feedback form for me. And it's very much anonymous, so you can, really write whatever you feel like. All right, guys. Some good reviews, some bad reviews. Someone also wrote I should become a faculty of VIT Bhopal. So I don't have the guts to do that. Neither I do have the PhD degree. But yeah, thanks for that too. So all right, I've made this is one of the two mini projects kind of thing that I found on Code Academy's platform. So I've implemented the same into Jupyter Notebook so that all of you can access them. So this is how it goes. Kept an instruction of I've kept the instructions. This is not mandatory. Earlier, I thought I should, keep it for the certificate completion, but it's all right. We've never, we are not going through the markings of the quiz, so we should also not go through this. Also, now after the instructions, that is how to use, and this is the video that I was talking about. That if you get stuck in the project, you could just simply go through it, and it is a video made through Code Academy experts. So they have basically pretty much included line by line coding of the whole, mini project. Although I would request you guys to not share this mini project to other guys who did not attend this lecture, because that is basically copyright infringement, because as a chapter leader only I could use it and the people who are participating in the workshop. So yeah, this is some project where you would be making a search academy, where you'd be having you'd be using linear search and binary search algorithms to find the empty or the fake data. So you could go through it. I've included step by step. So you do the first step, then the second, and the third. And by doing all the steps, you complete the project. So that is it about the mini project that I've given you. I'll share this file to you on the WhatsApp group as well as on the Teams. So you could try and implement. All right, guys. So this was it from uh, my side and from Code Academy VIT Bhopal chapter side for today's this all these sessions DSA Learn Week. I hope you liked it. I really hope that you learned something from it. And I hope you'd like to attend our future events. Coming up, we have an event on front-end development that is starting from 31st. I won't be teaching, but we have some epic guests from all around the world. It would be a week-long event where you'd be, introduced basically to React, JavaScript, and HTML, CSS, and Bootstrap. So that is what the event is all about. At the end, also, you'll have a hands-on session or something. For this event, you might have received a mail to the Secretary of Vice Chancellor. So you can check for registration, or else you will find links in the WhatsApp groups also. I hope you liked this session. That's all from my side for today and for this week and for this event. Thank you, guys. If you want to say something, you can say, or else you can. Thank you.
Bhaiya, I had a question.
Oh, yeah. Yeah.
So
doubts?
whatever we learned in this week, so is that all, or like we have to are there like other things that have not been covered in this week in these classes that we should learn about?
See, from the we've covered, actually data structures are very vast. I mean, where we have linear data structures, then recursion, then complexity, then, non-linear data structures like trees, hash maps, and all that stuff. So there is so much more to cover for you. There's so much more for you to learn. The reason I didn't include it in the web workshop series is that it would have been too long for you to, actually attend all the series, and it would have been hectic for me to plan it all and implement it all. So I guess I've given you a path that you can go on, and maybe you could learn more into it. Also, there are again modifications of the same data structures. For example, you asked that day, right? That what can we do with, like, for the queues and for the linked list. So we have, circular queues, we have double-ended queues. So there is always something else more to learn in any topic. So I would really suggest you to learn all these data structures. Telling you frankly, data structures are, directly proportional to what salary you get in the next year. I mean, in the placements. Problem solving, data structures, and whatever your development is in the domain that you have. These are the three basic points that give you a good job. So I'd highly suggest you to, learn these data structures more, doing the problem solving part also. We did the conceptual part. Now you have to implement them into problems, solve the problems to these data structures as per the usage, and learn more. So this is not at all, it's the tip of the iceberg, Nagni. You have to learn so much more. So, yeah.
What do you exactly mean by problem solving?
Problem solving, that is basically solving the problems. I mean, we have these websites, HackerRank, CodeChef, Code Forces, Lead Code. So in all these platforms, they have a set of problems they give to you. For there would be a problem which you can help solve with the use of arrays and linked lists maybe. So you should go and attempt those problems. After attempting those, you will find your weak points, then you study those weak points again, and then you reattempt those problems. So that is what problem solving basically means: solving problems by the use of data structures and the language itself. So
So
that
it's
is a
like how
good.
we solve practice questions.
Exactly. But the quiz problems that we did, they were not from problem solving. Rather, they were from the conceptual part, conceptual and the coding part itself. They were not actually problem solving questions. Problem solving could be like, you have to implement a list of VIT Bhopal students, and you have to calculate their grades and all that stuff and like that. And then they won't tell you that what data structures you have to use or what things you have to use. You have to do it by yourself within a given period of time, or maybe within given amount of memory, even sometimes. So that is what problem solving basically means. So yeah, you have to do that after it, and it would easily take about 6 months or 8 months to get to a good level in problem solving. It's like a muscle you develop. So yeah,
Okay, thank you, Bhaiya.
all right, all right, guys. Anyone else has any random question or any doubt from the session itself? No doubts? Then feel free to leave, guys. Thank you.
Thank you very much.
Thank you, Bhaiya.
Thank you, guys. Thank you, Pratham. Thank you. All right. Bye bye.
Bye.
Bye, Bhaiya.
Thank you.
Bye bye. Bye. Thank you. Thank you for coming. Like my body, yeah, money, money, yeah, I'm giving my phone, I'm always on my home. Critic on my life, Evidence of my horn, I don't need to fade. God of this. हो गया मेरा